Nathalie Edmond, and I'm coming to you today to talk to you about our brain and the way that it responds to stress, and maybe some strategies to help us learn to not live in fight, flight, or freeze. So one of the things I love to talk about is the triune brain, and I love how Dan Siegel talks about the hand model. He basically says, like, this is your brain. And this mimics, if we were to look at kind of like a profile view of our brain or head, this is our brain, known as the triune brain. And so what happens is, if you imagine that the arm is our spinal cord, and that's connected to our neck, and at the top of our neck is the reptilian brain, right? And so that's the part of the brain, the wrist, that we most share with animals. So if we imagine this part of our brain, it's our survival part of our brain. So that's the part of our brain responsible for our breathing rate, for our heart rate, for our sweat. It's very body oriented, sensation oriented. And then if we go to the palm, we think about the limbic system. And so the limbic system is like that middle part of the brain, and that part is our emotional memory system. It's a map. So all of our lived experiences live in that part of the brain. And then the amygdala, which is connected to our limbic system, that's our alarm system. So the amygdala, the thumb, is the part of our brain that scans the environment for danger. It scans the environment for anything that appears novel, different, not what we expect. I kind of think of it as when we walk into a room and we notice that something has moved, right? That's our amygdala saying, oh, something's off here, which is really great. That puts us on alert that perhaps somebody came in here, right? We think about the amygdala as signaling threat and danger. And the beauty of the amygdala is that it is meant just to notice, but not to discern and evaluate, is this actually a threat or is this not a threat? Because that would slow us down and increase the chances that we might be hurt if we took that much time to process things. We have a negativity bias built into our brain that allows us to assume the worst, and that helps us to survive. So why we mistake a stick for a snake, because if we didn't mistake the stick for a snake and it was actually a snake, we could increase our chances that we might die as a result. So the amygdala, just our alarm system, and scans the environment for danger. And then our fingers are our frontal cortex, our prefrontal cortex, the fingertips, and that's the front part of our brain, and that's the most sophisticated part of our brain that actually doesn't fully develop until our mid-20s. So the function of the frontal cortex is many things. It's our executive functioning, it's long-term planning and problem solving, it's our capacity to control our impulses, to have a dual awareness, so we recognize, oh, I'm triggered, but also, but I recognize that I'm safe or have some choices. When we talk about gratitude, compassion, those are all part of the frontal cortex. When we think about our capacity to see the bigger picture and observe and to build mindfulness muscle, that's all part of the frontal cortex. And in a well-integrated brain, all three parts of the brain are connected. So the reptilian brain is connected to the limbic system, which is connected to the frontal cortex, and they're all communicating with each other. So what happens, the amygdala, always scanning the environment for danger, notices some threat in the environment and communicates with the system, shut down everything that's not absolutely necessary for survival. So we flip our lid, and the frontal cortex zone of the brain goes offline. It's not available to us, and the reptilian brain kind of takes over the whole system. And we have a sympathetic nervous response, which activates the system to have the heart rate increase in intensity so that the blood flows to the extremities, the arms and the legs, and so that we can run or we can fight. And if the system is too overwhelmed, we can shut down and freeze, which conserves energy. And then when the danger is past, the parasympathetic nervous system comes in, and it brings us back to homeostasis, where rest and digest system can be online. Because when we're activated into that stress response of fight, flight, or freeze, our rest and digest system is not available to us. So This is pretty normal, right? So when the parasympathetic nervous system kicks back in, we go into all parts of the brain are back together, the frontal lobes are back online. So what we want to do is notice this, right? When we start to notice our symptoms, right, that we have difficulty eating, we have difficulty sleeping, it's probably because we're having a stress response, that our body wasn't designed to be able to both be able to rest and digest and to be in a defensive response, that it's one or the other. It's kind of like a light switch. And so part of building our mindfulness muscle and starting to notice where we feel things in our bodies, when is our heart rate increasing, when do we feel like running and escaping, we start to notice that noticing is the frontal cortex. And so that means it's online. So we want to do things that brings the frontal cortex back online. Frontal cortex doesn't tend to be online when we're on extremes of emotion. So when we're high intensity emotion or we're very low intensity emotion, the frontal cortex isn't involved. Frontal cortex likes like medium level of emotion and intensity. So there's nothing wrong with having a stress response. We have a stress response automatically because the amygdala just scans the environment for danger. But what can be really helpful is as we practice mindfulness, as we develop more awareness for discomfort, for a full range of emotions, the frontal cortex can be online, connected to the amygdala. You see how my fingers overlap with my thumb? That's the frontal cortex being connected to my thumb and being able to talk to it and soothe it and calm it down. So when the amygdala says, oh, there's something uncomfortable about that person, the frontal cortex can be that observer and say, that's just a memory, that's just a trigger from our childhood, that's just a trigger from this incident that happened, and that naming it tames it.